Thank you very much. So there's been quite a lot of activity in the North Sea recently in the CCS arena, and really focusing on both depleted fields and saline aquifers in the core of the hydrocarbon province. Now the question is, is there something else to look at, and should we step out towards the margin of the basin, something that was seen as non-prospective for hydrocarbons before? Would it offer us maybe a lower cost and maybe get us closer to customers? But what are the risks? What are the trade-offs? I would discuss these questions on an example from a Dutch offshore. I would like to acknowledge my co-authors here and the wider team that was working on this opportunity in Shell as a part of a Shell CCS ambition in Europe. I'll talk about demand for carbon storage in Northwest Europe and why we're doing it, and mention key storage projects that Shell is involved in the Netherlands. Then I'll talk about saline aquifers, specifically about lower Cretaceous opportunity offshore Netherlands. And then I'll discuss de-risking strategy for these sort of underexplored stores and potential development concepts that can complement existing projects or emerging projects. Now, this is a proof that we have lawyers as well. Well, my other slides are less wordy, but the message here is that whatever I say, don't use it for investment, any kind of investment decision, right? Now, we all know that about 50% of European industry emissions come from the sort of central east-west industrial corridor. And among other things, it includes 2 of 6 Shell energy and chemical parks. So it's naturally a focus area for us. And there are different things that provides incentive for us to get involved. There is legislation. There is increasing carbon tax. The projection in the Netherlands is that it will rise to $175 per ton. There are also subsidies, though, right? So both sides, stick and a carrot is out there, but there are also agreements, right? So there are binding agreements now in the Netherlands with top 20 emitters that lock in Scope 1 emission reduction, and Shell committed to 3.9 MTPA by 2030, mainly through CCS. So we have clear targets that we're going after. And of course, there are things like NZIA on the horizons. So the Netherlands, Shell has 3 capture projects, 3 refineries, 2 in the Netherlands and 1 in Germany that could be the emissions could be reduced by CCS in the North Sea. So we are expanding offshore storage and connecting to multiple transport infrastructures, or different ones. So we part of the Aramis pipeline project, the Aramis transport system, also part of Porto's first projects that are maturing, and for that, we are maturing a portfolio of stores, right? And they include depleted fields, and they include saline aquifers. There are challenges, as we all know, I'm sure. Many of these fields are ultra-depleted. They potentially have a cold injection risk. Depleted drilling is a risk. Saline aquifers, on the other hand, have quite a lot of uncertainty, capacity and injectivity especially. There are schedule dependencies. All of these things are moving. Any kind of delay in any part of the transport or capture projects affects storage maturation as well. And field access is an issue, right? And it actually costs something in many cases, right? Unless we really at the right time for when the field is empty and ready to be handed over to CCS. So let me actually zoom in on this area that is shown in that red dotted circle. So we are Porthos is the first CCS offshore project in the Netherlands. It's a project with a quite high state or government involvement. It has 3 state companies that are investing in transport and storage system, but also has a participation of 4 customer companies, Exxon and others, and Shell. It's targeting a depleted field, P18 field offshore, which is not that far from Rotterdam, and is looking at refurbishment of the platform and the gas production wells. It's quite a large investment, targeting about 2.5 megatons CO2 per year and overall capacity of 37, 38 megatons. So not huge, and I think it's definitely worth thinking ahead. What comes beyond? Is there potential expansion possible after the first phase of Porthos? And this study, what I'm presenting, is addressing that. So for us, the question is, should we look at another depleted field, or should we look at saline aquifer, or combination of both? They have different risk profiles, right? So typically, saline aquifers, fewer wells, potentially less containment issues, but they are not accessible, they're typically abandoned, so you either avoid them or they should be in a good shape. Capacity may be larger in aquifers, but storage efficiency is lower, so you need a lot larger area. You need to license a lot larger area and develop and monitor a larger area. Injectivity, sustained injectivity, is hard to de-risk in saline aquifers. But at the same time, they could be potentially cheaper and potentially larger, right? So cost is very important. So it's something that we should all consider. Another thing is time, right? So schedule-wise, many of these aquifers, especially if you're stepping out of the well-known areas, need more data, and that takes time and that takes investment, right? And it's also associated risk. So if you can wait for a bit, it's probably worth looking. And in this particular case, we are focusing on shallower saline aquifers of Cretaceous age. And the good thing there is that we don't really need conventional trapping mechanism structures. It's typically, what we're looking at is an open dipping aquifer, so migration-assisted storage. So before we identify a site, we don't just look very near the CO2 source. We've done our own regional evaluation, which was building on many of the studies that many of you were involved, probably regional studies. We do it in a slightly adapted process, which is stepwise. You're really kind of looking at the minimum information you need at the regional scale, sort of where are the right geological formation from reservoir and seal presence point of view at the right depth, and very soon we filter it out with surface constraints, right? So we look at where there is limited competition for seabed usage, where we have protected areas, where there is high concentration of legacy wells, et cetera, wind farm development. Then we define focus areas that we kind of go deeper in. So we then start looking at more geological data, looking at reservoir facies, faulting, seismicity, reservoir properties, et cetera. Pressure, depletion, and we start collecting legacy well data and looking at integrity. So once we actually zoom in and define those place segments, we try to rank them early on, and then kind of come up with some kind of realistic capacity estimation, which is something that would allow us to progress the project further. So once these sort of high-graded areas, the sweet spots, are identified, it provides a basis for exploration license, in this case, in Southern North Sea. Dutch authority invites applications for exploration licenses for CCS, and that's what we did. We looked at the two kind of areas where we targeting with different infrastructure, and we applied for quite large areas near K blocks and in P&O blocks down here. So talking about P&O block specifically, we believe that it offers up to 3.5 megatons per year, injectivity and capacity of up to 50 megatons. And that is kind of, we believe it's quite a realistic assessment based on dynamic modeling. It's based on extensive study work, where we also look at the appraisal that is needed to actually de-risk it and actually towards investment. And at the moment, we are in the process of license award. Really, we've been waiting since last summer. Hopefully, it will happen by the end of this year. Now, let me just briefly summarize the storage complex and the key subsurface and surface risks. So what you see here is a seismic cross-section and top of the reservoir map. So what we're looking at is this wedge of sediments at approximately 2 kilometer depth, which is sitting on this unstructured basin margin. So most of the hydrocarbon province is in this sort of folded and faulted area to the northeast, and we are looking at the southeast, which was not inverted or folded. We have quite a few seals above it, and we have quite a lot less concern about either through-going faults or presence of wells. At the same time, we're targeting shallow marine sands, which have producing analogs onshore. And we have a good geological model to explain a presence of quite an extensive fascist belt along the margin of the basin, which is calibrated by only 5 wells and 2D seismic. But there is an indication of tens of meters of amalgamated good quality sand in the lower Cretaceous, plus thicker formation below, which is more heterogeneous, but also could offer some capacity. In terms of containment, we looked at well integrity and we looked at fold reactivation. And long story short, wells that are actually in the storage complex seem to be properly sufficiently abandoned. Those that are not outside of the storage complex will be modeled, plume extension. It seems to be likely to avoid any kind of leak paths. But the fold reactivation might be an issue, and we need to look at what is the pressure that will potentially limit the injection rates. So this is an exploration project, and we, apart from trying to mitigate for risk, we also try to quantify the risks, right? So we looked at positive, negative evidence for why the project could fail from technical reasons and commercial reasons, as well as non-technical reasons. And we looked at how much we can reduce that risk by additional data acquisition. And we also looked at what it is that we need in terms of injectivity and capacity. So what sort of rates we need to actually to guarantee some kind of return that would give us, that would actually justify internally this project progressing. So that was quite important. And other than that, so based on that, we looked at, on the basis of the lack of data or of the sparse data nature, we think we do need a 3D seismic acquisition, and we do need 1 or 2 wells. You can do it in parallel, or you can do it sequentially, and you probably can accelerate it, but probably looking at 2031, 32 on-stream dates. It will not be easy to mature that, to actually acquire 3D seismic, because it's one of the busiest shipping areas. But we looked at it and submitted permit that authorities are aware of it. It will require a lot of coordination, but it looks like it is possible. And the last kind of comment is on development, and something about the surface constraints, right? So really, it's a large area that we're applying for, but if you look at all the shipping lanes and all the wind farm developments, etc., and the safe distance from whatever designated no-go areas, it leaves very little, which is in these black polygons, where you can actually put platforms in. Luckily, that's good enough still for the project to go ahead. So, we are very constrained, and we'll need to confirm that in these areas, properties are good enough to develop this project. And I will not go into details, but it's not far from Portos. Probably can put pretty low cost, very small platform, one well per platform development in there to give us that up to 3 MTPA per year. And to conclude, we believe that saline aquifers offer a viable storage opportunity to complement depleted fields, and they minimize the overall risk of the portfolio. Specifically lower Cretaceous aquifers in P&O blocks can add significant capacity to first mover projects like Portos, and they offer large capacity upside. They also potentially lack the cold injection risk and field access cost. But exploration and appraisal program is required before really a contingent storage resource can be declared. And however, we are progressing with the project, and permitting is in process, and we hope to get a license awarded this year. Thank you for your attention.
Right, so, and I